let it bang, bang.
Now let's implement merge sort. Create a file, save it as a merge sort. Okay, so first we will implement the merge function, right? We will first implement the merge function. Okay, so merge function. So first define a list. In this case, let's take we will take two sorted lists, 4 5 6 and 1 2 3. So ultimately we want that to be sorted. We have taken two sorted lists and then we will see that if it's sorted or not. So nextly we will create a function merge. In this case we will pass list, the left index and the right index. And what left index here, it means that we have to give the list starting and beginning and the middle one in order to separate these two lists from each other. So right index and the third parameter is middle. So we will divide it into the two lists. So our first list left list left list is my list, and we will do slicing here from the left index to the middle. So if our elements are 6, then 6 the in model integer division will be 3. So here 3 will be, so our list will contain elements 0 1 2. So similarly, in the similar way, we will create right list will be my list of the middle index and till the right index till the right index, right? Okay. So if we have 6 elements, so we will it will go from 0 to 5. Now let's check if our list is divided or not. Now if we run it, okay, we have not called the function, so we will call the function merge by giving the parameter mylist and the starting index, and the ending index will be the length of the list, and the middle index will be 0 plus length of my list, and we have to give it by dividing into the two. So it will do the modular division for us, matlab, yeah, integer division. So when we run it, we will see that two lists, we have gained two lists here. Now the only step is to sort these two sorted sublists. So we can comment this, and now we can start with the we need few things like left list index. So we have to know that from where we are going. So it will happen like in this manner. First we will see that if we will start from here and we check if this first element and this first element are sorted on, are if this element is less than this element. If not, then we will uh, increase this pointer from here to here, and we will take this to first position. And then we will check again and we will increase the pointer here. So like this we will do and increase the counter, and after this list are finished, after this list is finished, then the only step will be to join these elements to this list. So in this way it will be very quickly, and if this element is less than this element, the only step is to take this element to the first position. So it is a in place sorting. So we will sort these elements in the same list itself. So the next step will be left index, let it be 0, and then we will take our right index. Right index, it will be the left list index will be the right from here. From here it will be 0, and the right list index will also be 0, because we are not talking about this list and this list. So the starting index of this list is also 0, and this list is also 0. And now, as we have talked about that it is a in place sort, so we will like that index sorted. So we will know that which index place is sorted till when. So we will give here left index, because at every stage we will see that we start from the left list, and we move on to the indexes till it is sorted. So now, as we have given the index sorted, the only step is to sort it. So we will now check that both lists have elements. So how we can check it? We have to check it that left list index is less than the length of left list, and we have to check that also right element is also right list also have elements. So we will check this by right list is less than length of right list. So in this way we have checked the one condition. Now we have to move on to another conditions. So the another condition is the that we have to check this if this element here is less than this element. If that's the case, then we have to shift this position. uh, we have to swap this change the original list with this element. In this case it will be already occurred, and if not, if this element is greater than this element, so we have to swap this position, this element to this position, this index. So we will implement that code here. We will do like if left list of left list index, if it is less than a right list of right list index, then in that case we have to make the original list index sorted position by the left list element. And after we have done it, we have to increase the counter of the left list by 1. And what does it mean? That after we have checked that this element is less than this element, but in this case it's not, but if it was less than, then we have to simply move on from here to here, and the first index as it is sorted, so we have to move from here to here. So the another step will be to increase the index sorted will be +1, right? Similarly we have to if it that's not the case, and if it is greater than this element, so what we have to do in this case, we have to write that this list of index sorted will take the position of the rightmost element, this element, right list Yeah, so it will take the right list position, and now the similar step will be to increase the right element by 1. So we have to take from pointer from here to take the pointer from here to here. So we will do right index plus 1, and the next step will be to increase the my list index that it is sorted by 1. Yeah, so this step as it is completed, the only problem is there that if one list becomes empty, like in this case, when we will check this first element with all these elements, these three will be these three will be changed here, but now this list become empty, so we have to take this list and we have to just paste it here. So the logic will be while we have to check which list has become empty. We will check if left list index, if it is not empty, here we have to give in a array manner. Okay, right. Few changes. Yeah. So if left list of left index, it is less than, oh, just wait a minute, we have to check that if this index is not empty or not. Yeah, so this should be less than left list. If that's the case, it means that this list is not empty, it has some elements, so we have to swap these elements to the original list. So we will do index sorted, and we will give the elements of the left list. And next we have to increment the pointer of the left list and the index sorted. Similarly, if the right list have some elements and the left list become empty, so we have to first check if the right list has some elements. So in that case we have to do these steps. So we will simply go on and we sort this. So in that case our merge function is now complete. Now we have to just check it if it works or not. So now we will at last print our original list as it is in place sorting. So we will, or the original list itself has changes. So here we have just made an error. What we have to do here is we have made these lists these condition inside this condition, so it will not work properly. For that purpose we have to take this these lines out of the box, out of the scope. And the purpose why we are doing it here, you will, if you see the code, you will understand that when we see that these lists are empty, so we have to come out of the situation, come out of the loop, and we have to check that which of these two conditions are making the program to stop. So we have to check them individually. For that purpose we have to come out of this loop, right? So in that case we will see that this will work now properly. So now let's run it. After running we will see that our two sublets are sorted.
Let it bang, bang.